thank you for coming to this tutorial. In this tutorial, we're going to discuss MySQL scaling strategies for MySQL, so less or even almost no hands-on, and just me talking the whole way through. So you don't need to do too much. Just listen, and before I lose my voice. Well, my name is Jonathan. I'm a MySQL consultant. I've been working with MySQL since 2007, and I specialize in SQL indexing and reporting. So a lot of the things that I'm hoping the people in this room would be interested in, and the people in this room, so that the people who this tutorial was intended for, was people who are developers, in the sense that they have control over the database usage and even control of the caching, but may not have control necessarily over the hardware or the server OS, or maybe even the MySQL settings. So things that within these realm of control that you can affect the performance. And I have to say, these two areas can do, like, the vast majority of your problems can be solved in those areas. And I think we're all here to answer the following question, and that's that: why is the database so slow? At least I hope. Oh, by the way, throughout the presentation, I decided not to spend money on iStock photo and just put internet memes, and I hope that you enjoy it. And I encourage people in the future to just use internet memes because it looks funny. I will not cover a lot of the knowledge. I think I'll cover like 20% of the knowledge, and I think honestly even 20% of 20%, because there's a lot of information. I'm giving you strategies, so it won't be a lot of information, but I'm hoping that the information I give you will solve you the vast majority of your problems. So like when it gets more technical and when you've optimized it to some degree, then maybe you can take it off, you can go off on your own and find the solution. Or at least give you like the theory to go in the right direction. So I may not give you all the answers now, but at least which direction the problem may lie and where you should go to find the answer. And I'm also hoping to give you like advice that isn't risky, or at least in my experience, what I find is has been more common, techniques that are more common, or at least have some Google results if you need to get some help about them. So yeah, basically, just to summarize again, the top 20% of strategies for developers that are common and established from my experience to reduce risk. So the risk, I think, is important. I think, like, if you come out of this conference and you see like something really cool but no one's using it, and you recommend it to your company and they use it and then it doesn't work and you get fired. So I'm trying to avoid that, at least. Well, I'm as a consultant, so giving good advice to my clients is very important, and I'd like to give you the same advice. So I have it's a really long tutorial, by the way. I have 3 parts. Part 1 is indexes and finding bottlenecks, 2 partitioning, and intensive table optimization is something that I'd like to show you. It's more of like the lean approach to databases. And then part 3 is just discussing stuff. So in the first 2 parts is actually some not really exercises, but some technical stuff, and here it's just discussing strategies, really. But everything here is hands off, and I will basically show you how I do these techniques, or how these techniques can help you. So let's start with indexes. So basically, I know that some people here are like intermediate, or like this is a bit boring. I'll try to get through this as quickly as I can. So you can't see very well. So basically, this is like an index of a book, and pretend that's like you need something, and you browse through the index, you find something, and it tells you where it is on the hard disk. That's at least the idea, and the idea is to not go like a full table scan all around the hard disk to find what you're looking for, filter it, but to get directly there, pick it up, and continue. So it's very much like a telephone book in that sense. And obviously the advantages are speed. And by the way, I still think that like indexes, my blog is even called indexes and caching. I still think that solves like 90% of the problems. All the performance audits I've done, and when I worked short time in Percona, all the performance audits that I've noticed, like the vast majority of them, indexes solve the speed problems. Even some NoSQL stores use indexes. MongoDB for one, and even Hadoop has technically indexes, but not really in B-tree sense. And a properly indexed database will give you very few problems. Right. And also, I'm going to assume that for the purpose of this presentation, you're all on InnoDB. Even if you're on MySQL, the information I'm giving you is for InnoDB. I'm making a lot of assumptions here about what you know and don't know as well. So basically, the idea of a B-tree index, but I'll explain. Don't worry if this is like if you don't get it right away. It's kind of like based on levels, on layers, and you go to the top, and then you know what? Actually, I'll show you a video. It's easier to explain. Yeah? Can I play it, please? Right. So this is an example. You can get this on YouTube, by the way. Here's the link. This is you're seeing data inserted into a B-tree index and how the index is getting more and more layered. And basically, it's like I'll repeat this throughout the tutorial. But as you can see. The more data you have, the more layers you have a bit more, and you're starting to see like there's some movement in the B tree. Like it needs to form another layer, and then it needs to reduce a layer. When in a bit more you start seeing deleted. So this is a very visual way I thought of showing you. See, look, it's doing some work. It's not like if you have a table, the larger it gets, the more of these you will see. Can I actually let you watch it a bit more? I think soon we'll start deleting them. The music isn't very good, is it? I think it's Russian, so I'm not sure. Is it Russian music? No, it's not Russian music? I thought. No, it's Turkish music. Sorry. Okay. Okay, I'll take your word for it.
Or Georgian or Armenian.
So here, when you see like the layers there, it's splitting them. I think you should soon start seeing them getting deleted now. Yep.
Can you explain why cells have only two places?
The minimum maximum, so like it creates it. So if like you're less than this, it goes there. If you're more than this, it goes there.
Why so many cells don't have maximum?
I'm not sure exactly. You know, I'm not sure about that, but yeah, the idea is that when you go to a layer, so maybe like it's to keep it like the maximum. This is the maximum. So if it's above 16. Go to this side. If it's less than 16, go this. If it doesn't have a maximum, more than 16, go to this side. But that's basically you go down the tree. Okay, so I hope that was helpful to understand. So indexes make things fast, and why not index everything? So if you index everything, and I'm going to discuss this also in further along in this tutorial, you get a situation where you just have too many indexes and pretend this is like an old style library, where you can actually have a situation where the books that you're containing take up less space in these indexes. The data that you're containing takes up, like the indexes start growing larger than the data. And also, if let's say you have 5 indexes for a particular table, and let's say you want to add a new book to the library, and you add a new book, you write it on a card, then you write it on another 5 different cards. You have to write it and place it in the indexes. So it's kind of like helps you imagine like how much extra work you have to do when it inserts, updates, and deletes. So I'm going to discuss to you about the star, Stefan, the star method for indexes, the three-star method, yes. So. Is this a bit bright, or can you all see it okay?
It's a little bit bright.
It's a little bit bright. So, yeah. So this is like green. So it has where equals. I'll explain why. This part, this is like 1 star. It prevents table scan. So again, like with the example of the hard disk, you go directly to where you want on the hard disk and not scan the whole table. This is a 2nd star. Obviously, the index takes a bit more space. So you have like. On your index, you have 1 column, then you have a 2nd column, or 3rd column, or 4th column. So this, for the 2nd star, is supposed to save you doing group by or order by. Okay? And the 3rd one is supposed to contain the select variable. So it doesn't even go to the hard disk at all. It's all from the index. It's all hopefully from memory. So 1 star will be like an aware. 2 star will be for group by, order by. Prevents extra processing for sorting and grouping. And the last, and 3 stars, it means it's very efficient in terms of finding the data. It's also the index size is a bit bigger. Prevent reading from disk entirely. That's called the covering index. And I'm also assuming that you know explain here, so I'm making so many assumptions here. So a 1 star in the explain statement, when you're trying to find if this is a 1 star index, when you look at the column type, just take my word for it because I'm not giving you an example. When you're looking for the column type, you're looking for something that I said one of the three things. Idle const, well, id equals 1, so it's a constant. Reference, well, where equals, there's an equals here, and that's important. Some random, is it? Or you're joining into another table. And in the extra part of the explain, it says using where. The limitation in this index is if you're doing a range scan, means between two dates, like some string with a wildcard at the end, you can still use this index, but you can't continue to the second star. So it will still, using index for this will still help you get results faster, but the limitation drops off. Actually, I could have rewritten it. It drops off and you can't go to a second star. Second star. In the extra, you're using either where using index, but you shouldn't see if it's a 2-star index, using file sort or using temporary. So using file sort is for order by, because you're sorting, and using temporary is for group by, correct, Stefan, so far? Okay. Stefan is quite an expert on this himself. The limitation here is that if you have a different column for the group by in your SQL, a different column for the order and a different column for the group by, then you drop off. You can only get 2 stars with it. You can either improve the order by or improve the group by. You can't improve both, and you won't go to a covering index. And then you have covering index 3-star. You'll see in the type index, and you'll see in the extra using index or using. This is I think new for 5.6. I'm not sure. Using index for group by. So completely done in from the index. Almost no reading from disk, very, very fast, and if you can, obviously use it. I'm going to give examples now, so do not worry. You have plenty of examples to go over this, and they're all colorful. Can you all see that? Okay. So this is a primary key example. Omega is primary key here, and you know that in InnoDB is clustered index, so the primary key actually holds the data. So you have the primary key to find where the data is stored. In the beginning, when we saw that movie, you're sorting it. Sorry, when you insert it, you're sorting by the primary key. So if the primary key is 1, it will go to one side. If the primary is 30, it will go to the other side. So you're sorting it by the primary key, and with the primary key, you're adding the data as well. So this can be 1 star, but it can also be it can technically also be 3 stars. Is that correct? Anyway, primary key is very, very fast search to do in any case. And here you have a range scan, where we have. So here we have two where clauses. We have one which is an equals, an exact, and the second one we have a range. So this is a 1 star. You cannot get a 2 star. You cannot get a 3 star here. There's no group by, but you cannot get the covering index, because after the range it just drops off. No matter how many columns you add, it won't read them. Here we have a covering index with the previous example. This is a key, so you have the omega, and then you have the 2 variables in the select. This will be completely read from memory very, very fast. Here we have something not open again. So you have here the omega. You don't have the musical sign, but you put in the 2 columns from the index, from the select variables, and it just won't do anything. It will do the omega, and it will drop off. It won't help you with the other 2 variables. Here you have a broken range. Well, the musical sign is first. The range one is first. You will not use the second one, so it's not optimal. It will just use the range scan on the music sign, and that's it. And here is a subquery. Well, this will help the subquery. Obviously, I think actually this isn't such a bad subquery. It would be worse if here it may be materialized before you do it. It's not so obvious. Still, it's better to do a join. But if you had a where something from the previous table, then it would be slow. Then you would do it per. But here it might even be materialized ahead of time. It won't be that bad. here you have index for sorting, so you have the index for the where, but you need to pick one for the, you can pick one for the either group by or order by, and you can choose one. And I think because you have either group by or order by, you can't proceed to 3-star index. Okay, it's getting a bit more complicated now. We have indexes for joins, so select T table ID, user sign, user ID. You have like the omega sign for the T table, and you have the ID sign. This is ID, and you see that ID is what the table is joined on. So TID and that table user ID, that's what they join on, and then you have another where to do a filter on. So it kind of like looks like this to help you understand. So if you were to do it, there's two ways to do it. If you were to do it with you take the first table T and omega, and you do equals 232, it will go through the table, filter out where it says 232, and take those rows, and then join them with the other table on that ID. But here you're not using the index to join. You're using the index here to join. You're not using the index here to join. Here you're using an index. Here you use the filter. You have these rows, and it's kind of like a loop, like a cursor. Because one looks at this table based on the index that is here, and then it outputs the result at the end. So the other way to do it. Sorry. So if this table is very, very small, your explain will just say, look, this table is very, very small. There's no point going to the larger table and filtering it. You will just do a full scan on a smaller table, get those rows, inner join them to here, and filter it a bit further, and then output the result. So sometimes the MySQL optimizer chooses to do like a full table scan. You think, why is it a full table scan? Why isn't it using my big table with the indexes? And the reason because the table is doing a full scan is very, very small, and you're doing inner joins on everything, and you're doing inner joins on many things, and that small table has an inner join, so it decides I'll use this small table and just reference inner join to everything else. So I had this thing when someone came up to me and asked me like I need help optimizing the MyCNF file, and I said, can I see one of your worst queries? Or anyway, I got him to show me the queries, and it was like really, really bad. It's worse than this. And the first thing it goes, it's MySQL is slow. I need to optimize CNF files, and I would like to say that the SQL and the indexes do a huge, huge difference. So just get them, like adopt the mentality of looking at those first, because that's usually like at least you see the database usage and see what the problem is. So a few interesting things. This is new to me. This is only discovered this year. The primary key is in your key, is in each of the keys. So like if you have a primary key of IDA and this is your key, the primary key is as if it's at the end. But it was difficult for me to make use of this key. So for example, sometimes primary key, it's not ID, it's like date and another key. So I can have like a primary key with two columns, which are still unique. And I never was able to get like make use of it. And then like I found out that if you want to use the primary key to help you group by or order by, or use the covering index, it does actually work. It just doesn't help you in the where. So you can see it here from this link why it works, and you can actually make use of that primary key within your index if you should want to. Sometimes you have something called an index merge. I think in 5.6 they kind of did something called index conditional pushdowns. But anyway, right now, let's say if you're not using 5.6 and it's not out yet. So if you have a situation when you have an OR and you have a choice of using either one index or another, MySQL will do an index merge, and it will kind of look like this when you have like select from. It will as if it looks like this. It gets data will search the table twice and merge the two results and gives you the results. Sometimes it's not the most fast, but it's an option. And I think with 5.6, and I've written myself to remind me, you can do a key with both of them, and it will kind of figure itself out. Okay, so if you have OR, that's something to keep a look of. And then we have, and again, like all this. These additional things with the indexes, it really makes a huge difference, and I can't really like. recount the times of how many times I made a change in index and everything else works fast. It's kind of like this. So yeah, it really does give you like that cathartic moment where you're like, yes, everything works, I made a huge difference. And yeah. So now we're going to do finding bottlenecks. I'm going to give some okay, sorry. So in the finding bottlenecks, like you're looking for the queries that are causing the problem. You're looking for how the database usage is slowing things down. And I'm not going to, so this is the way of finding like bottlenecks in finding the queries that cause bottlenecks. So new queries, for example, if you write a new query, you're using explain. I don't need to show you this. If you have a slow web page, you can use tools like Filebug that will show you all the queries in the web page. But what happens like if me, for example, I go into a new system and I want to just see how the system performs in general, and I want to find like the overall slowest queries. And if you have queries that local, how do I find them? I'll show you that now. And some MySQL setting, but I won't go into I/O necessarily. I'll just recommend things you can do. So finding the worst queries, basically I do. So I either do like. Is anyone here familiar with Query Digest, the tool from Percona? No? You're familiar? Okay. So I use Query Digest. Basically, I'll explain how to get it, but I've tried to find I get the slow query log. I try to find the worst queries from the slow query logs, and I also try to do bulk queries. So that's something I look for as well. I'll explain what I mean by that. So to gather this data, what you need is basically you need to get the MySQL slow log, and to get a decent slow log that gets like not just seconds but like 0.001 seconds. 0.1 seconds. You need MySQL Highland 5.1, or you can use the Percona or MariaDB, which have a micro slow patch and additional information. So either one of these. I'm hoping everyone here at least has 5.1. I'm not sure if there's a 5.1 in a particular version, but that's what I understood. And what you do is you need to get like basically you want to monitor the whole system, so you need to set the long query time to 0. So write everything. It's like a general log. Everything is written to the slow log now, and you can set it to like between 6 and 24 hours. You want to get like a decent size to know what's going on in your system. Then you process it. And to process it, you basically use Query Digest. What I do is I blank the slow log, like I do echo into it. I set the long query time to 0, flush logs, and then I wait X hours, and I get like massive. Sometimes it's like really bad. It's like 3 hours pass and it's 7 gigabytes. And then basically I process it later with Percona Toolkit Query Digest, and I also recommend that you don't do it on your Microsoft because it's very, very CPU intensive, very resource intensive. So download it to copy the slow log to some other server and process it there, either like something that's not that relevant. I also look, if I want to find bulky queries, and I classify bulky queries, the ones that like process a lot of logs, a lot of rows, because I find that these either like use a lot of the resource of the system. So you can just add like a filter here. You don't have to really, but you can just add a filter here. This is just 1,000 rows is something subjective, so you can change that. Or if I just want to get like the right queries, like I want to see what's written, you can do like, you can filter it, or of course you can go to the binary log, but in any case, just do like a slow log and just get the query digest on your slow log, and it should be quite enough. And also in 5.6 you should have statement digest, so you don't even need to do that. You will just get like a view. You won't even need to do. By the way, this processing these logs can take between some hours to like a day. You wait a day, then you wait like 8 hours, depending how big your server is, how much it does. It takes a while. So this is the output you will get from PT Query Digest, and like you really need this tool. You have to like learn this tool. And I'm presenting this tool. I'm cutting out a lot of information, just showing you what you need to see. You really need to get very familiar with this tool. And I think, if I'm not mistaken, Box.com have like a tool to use information from PT Query Digest and present it like in a graph. It's a bit difficult to set up, but anyway, you need to really get very, very familiar with this tool if you want to monitor your servers. So this is the output you'll get, and I'll explain what it means. Oops. So, yep. So you'll automatically get the rank by the worst response time. And the worst response times means the call time, how many times this query was called. This is like a summary of the query, and how long it took to run. So if it was like twice, but each time it took 30 minutes, it may show up as first. And what you're looking for is this big juicy numbers to say like, look, this is 16.3% of my all my server for 24 hours. If I fix this query, if I add an index, and then you say bring it down to 3%, right? I've given you back 13% of your overall server capacity. So you're looking for like nice big juicy numbers to like kill it and like make a really big improvement. And yeah, so you sometimes get things like admin int or set, but they don't mean much, right? They don't mean much.
It means that there's a problem when with your application. For instance, with set, it means that you're doing much set statements.
Yeah.
I think it's bad. You should set up your MySQL file correctly. Your client should not issue a set statement each time it tries to connect with you.
If I tell you this is Drupal, what would you say?
Yeah, why not?
Possibly?
Maybe. Yeah, it's quite common to have admin statements or set statements.
Okay. So this is Drupal. You see like the DP underscore. It's not necessarily what Drupal gives you, but this client decided that they had their own tables and Drupal tables, and they want to differentiate. So this is from a Drupal website. So what you're looking for is like really like the worst queries and like stamp them out. Like take the first top 3, and like ideally this is a bit spread quite evenly at this point. I actually made that 16, it was 6, but let's say if you have like 54% or 26, and then you have like 0.1. Just get like the big ones and like stamp them out, solve them. Now I'll explain how to get a bit into locking queries. So I actually don't do it like the Percona people would, because the Percona people will probably install like PT stock and like put something like that will monitor the system, and when your system gets overloaded, it will write down to a file what's going on, and you can't really see anything what's written there, but it's written MyTop query digest. This one down here says show InnoDB status, and the last one is query digest thread. So the idea is you're trying to find locking queries. You won't find locking queries in the slow log, because the queries that are slow because someone else is locking them, the queries that you see there that take a long time are slow because someone else locked them. You won't find the one that is locking, you find the ones that, as a result of someone else locking, that they became longer. So what I do is like sometimes like an idiot just do like MyTop or process show process, like see where it is, then go to show InnoDB status, and I'll see something like this. Wall of text, right? Does anyone make like perfect sense like right away or not really? Okay. Don't really focus too much. I'll tell you what you should focus on. So this particular query is from a client I was working with, and they had a currency conversion function, and in that function they had SQL, and every time like you would process something in the row of that table, you need to convert, so you would run this function. Let's say the row had like 100,000 rows. The function would run like an SQL. It would like leave the server, come back into the server through the SQL optimizer and the SQL parser, and run it and return back. So it was quite slow. And as you can see, it's locking currency, it's locking daily summary, and it's locking exchange rate. All these tables are locked in IS mode, S mode, S mode. One is reading, and someone's writing, but it's too many locks printed. So you basically will find it in the show InnoDB status. It's a lot of information. The show InnoDB status is for the developers really of InnoDB, and it's a lot of information for them. Try to find a query that's locking it tells you what it's locking, how many tables and for how long. This is another example of doctrine. That doctrine had some kind of lock tracking, and I don't think this actually says it very well, but the primary key had 2 columns. It had 3 columns in total. It had 2 columns, or maybe 4 columns. Two columns, and it actually should have had 3 columns. And what happened? It had a gap lock, so it would get like all the queries that were answered by the first 2 columns, but then let's say it was 6 rows, and all those 6 rows were locked. And because it wanted to lock the gaps between those what it replied to. The index was on two columns. It got that was 6, locks them, makes a write, but to only one of them, but it locks all of them just to be safe. So I changed the primary key to include the last one, and then it just locked one column. So gap locking is something also that you should watch out for and causes locking. But usually, like things like gap locking or just queries taking a very long time and requiring either to view another table or insert into this table, select star from, you lock both tables. You're trying to find queries that take too long to complete and either reduce that or break it down or write an index like I've done. So basically, for looking queries, you try to make them as fast as possible. Some tips for that would be like to do joins instead of subqueries, to not have functions wrapped around an index. So if you have an index, you have where date equals something, but around the date you do, no, forget that. Where email equals something, but the email you wrap with a function called lower, like to have lowercase. You can't use the index on email anymore because you've just wrapped it in a function. UDF within SQL, a user-defined function that has SQL inside. I don't think anyone here actually has done that, but it really increases the time a lot of something to complete. Any really long transactions, try to keep your transactions as short as possible. Don't have them too long. The longer it is, the likelier the chance of having locked queries. And also basically like loops with very short queries. So you have like your array, and for each one of the thing in your array, you do like a short query to the database. If you do query digest, you'll find this exact problem. You will find these kinds of behaviors. But if, for example, you look at like the slow query log and you set it to 2 seconds or 1 second, you won't find it because it's just a lot but very fast ones. And sometimes when the MySQL optimizer is a bit confused and you need to give it a hint in which one to use, I'll show you how you can use this in a more safer environment. But in some cases the optimizer is confused, or the data in the table. Let's say you started off when you were developing on your environment. You started off with like 200 rows in one table and 400 sample data in another table, but now it's 1 million or 20 million, and the index has gone like in a different direction than when you had initially done explain statement. So the optimizer changes that depending on the data of the table, the information it gets from the table. So if you want to tell it forcefully where to go, you can either recommend to use index. Force use is just a recommendation, but it's still go there, I think. Force index is to force it. Ignore is ignore. Straight join is if you have two tables, you're joining them. It will take the left part of the table first, join to the second. It won't give you the option. It won't give you the option of taking another table. First join, take the left table and join to the right, and you do straight join instead of join or inner join or left join. And sometimes, not always, but this is a bit unusual one, but sometimes left join is faster than inner join. Not always, sometimes, because inner join basically you're filtering rows, and left join you're just attaching rows. So the optimizer will understand differently. Like I had like a really long reporting query, worked very, very well. Someone added like another table to join on, just to get like an ID and get the description of the ID or whatnot, and nothing worked. And here left join kind of like told the optimizer, look, I don't need you to filter on this table, just get it to describe the ID or whatnot. So just and again I'll give you like examples of how to set up an environment which you can test these things or try these things. So you can see this, but this is out of scope IO bottlenecks. But if you do want to see what's causing IO issues, I would recommend IOstat a bit more and VMstat a bit more informative. In my mind, although it's a bit wrong, is IO top, which you have to get. IOstat and VMstat you probably can get like very easily already. It just kind of shows you which things are taking up IO. So you can see MySQL, you may see like journaling of ext3 systems. You'll see all these things. But this is out of scope for this presentation. So bottlenecks and how to. So I'm just giving you like really samples of what I've done. This isn't. I'm not explaining why, or I can explain a bit. Just like samples that will help you solve your problem. So with virtualization, I have worked on a few virtualized environments. With virtualization, if there are problems with erratic I/O, I try to increase the InnoDB log file size. So give it like a buffer. I usually increase it quite a bit, depending, but there's a way to calculate. But if there's erratic I/O at some like 1 a.m. or something, and they don't know, just increase it quite a lot. It will give you a buffer to keep statements before they're written to the hard disk. So if like you stay within this buffer, or like an increased buffer size, then you won't notice anything, or MySQL may not notice anything. Making a change to this requires a restart to MySQL and deleting the old log files. Particularly, I've also had a problem with ext3. I'm sure that some people here have already used ext3 with virtualized environments and they've worked fine. I had a very serious problem, so I'm going to tell you about my particular use case. I don't know if it will affect you or not, but I did some work for a company when the iPhone 5 was released, and the server just hanged, and it was very unusual because it wasn't like MySQL like eventually got full and then hanged. It just hanged like instantaneously, and with all this benefit of virtualization, we had a very difficult time finding out what the problem is, because it had many layers. This virtualization, it was by a hosting company. They had the SAN, they had ESX, VMware server and all that, and each particular layer had an expert and everyone was blaming someone else. So I got out from this experience, and I'm sharing with you that ext3 had a lot of journaling and caused some problems, so try ext4 or XFS. But, you know, you could be running ext3 now and perfectly fine, just recommendation. General I/O improvements, so this is also valid to virtualization. InnoDB flash log transaction commit. So basically, this is, I'll talk about this later a bit more, but this means that you can either flash whenever MySQL has given you like an instance and something to make a write, you can flash it immediately to disk. This is obviously the safest, most ACID compliant, but the slowest as well. This will be =1. I think it comes by default. I think it does. If you set it to index to =2, it does it once per second, or when the OS does a sync to disk. If you do it =0, it does it once per second. So this will obviously be faster, but less ACID compliant. So if you miss something in that 1 second window, then you may not get it. You also have sync bin log. Sync bin log basically means that every time you write something to the bin log, you sync it immediately to disk. So you will always be in a very ACID compliant state. If you change it to 0, I think it doesn't do it immediately. Sorry, it doesn't do it immediately. But just imagine that all the queries hitting your server have to wait to be written at the end of a log file. It's like it's a sequential log file. It's relatively fast, but like that's like some kind of a bottleneck there. And XA support basically means that if you have several queries trying to make a change, you need your binary log will store it in the order it came in, and with XA support false, it will just store it like whenever, it will store it together. So if you do this, and it's important to keep it like in the same order, then you may lose something when you replicate. And these two things are so if you don't have this issue with your database usage, you can set that as false. And that again helped with my ext3 problem, but I think with group commit that we have now with Percona server and MariaDB, these two are a lot less of an issue anyway. But Stefan will have to tell me if I'm right or wrong, I'm not sure. Another general I improved, so I use Percona server, I really like Percona server. And it has basically, even the 5.5 now, or since it came out, has a much better flashing to disk algorithms. And it has less mutex, I feel. So the first one is definite. The second one is, yes, I think 5.6 like has incorporated some of these things that Percona server have done, but I use it quite a lot. And sometimes when you have issues with I/O, really try Percona server, or you can try upgrading MySQL. Depends. So in later versions of MySQL, in 5.1 and 5.5, you may have these things. By the way, I don't get paid from Percona, so it's just my advice. And there's another variable called InnoDB I/O capacity, and that's basically the rate in which you write stuff to the hard disk. You can calculate this with this link. It doesn't have to be too high, but I think the default is the default was 100 on 5.1, 5.5 was 200, and I have some servers that have it on 800. You can do 500. It really depends on your RAID on whatever you have, you can calculate it. But if you increase this, you can save things faster to your hard disk, so that may be something to look into. If you do it too high, you may clog the system. You may write too much and everything else has to wait. So with caution. In my presentation when I wrote it, in my tutorial when I wrote it on the web, I gave the option. I gave some advice on how to do database upgrades. So this is perfect for you guys, really. So MySQL source for smooth MySQL migrations. You upgrade to the version that you want, the MySQL version that you want, the dev or staging DBs, the desired version. You wait 1 to 2 months, right? Till everything is, all the features have been tested. Everything is, all the queries that may have conflicted with this new version have been taken care of. And then those very, very little issues. Yes, you do have tools that can replay the logs. Sorry, I'm already losing my mind. Can replay the logs. And yes, you can do these things, but I find that this is the most, because you test everything against the database, this is like the most foolproof way. And then when you do upgrade the service, you upgrade down to up, so the slaves first till you reach the master. Okay? And Percona does have tools, to play the log, play the verses against two servers, so one server is this version, one not. Did it give the same result at the same time? It does have all these things, and they're great. They're really good. I just find this is the easiest, or the safest. And homework. So I haven't really talked to you a lot about everything about SQL and explain. I'm assuming you know these things to some degree. So I'm giving you homework. You can watch these 7 webinars, both by Percona. The tools and techniques for index design, I think, is really, really good, from Bill Cowan. And he's actually going to do something tomorrow which will do that, so you can go see that. Or you can see the webinar at your own leisure. And this one explain the method, but it's not exactly how I view it, but from Baron, it is very good. There's a new website by a French guy. How's it called? Citric, sorry. He released something quite good. I like it. It gives a lot of examples, so you can study this. You have to basically feel confident about this and take this on your own. Okay? So, we're doing actually not too bad for time. So, part 2. So, do you have any questions so far? I think I just did it a bit too fast. Because last time I gave this the one with the indexes first, and they said it was way too slow, and they loved all the sharding, and which is in the third part. And so, do you have any questions at this point about what I've already said, or are you all just dumbstruck by everything I said? It's way too fast, and you didn't understand. Does anyone with the query digest? So that's the tool that I feel is really very, very important. So if again, it's to get the behavior of the overall database. Sometimes these queries just slip by, someone wrote them and they've been going on for a few months now, and the database is slow and no one understands why. And to get the top query, if you find that one really, really bad query does 54% or something, even 98%, right? Really slows everything down. And you fix that, add an index, add 2 indexes, 3 indexes, or whatnot, or change the SQL, you can really make a very big improvement. And I'll show you a bit further on a way of doing that, experimenting and finding the best way to do that. I guess I'll continue. So now we're going to talk about partitioning. Quite exciting. In general, this partitioning has given me, the way I've used it and the way that I'll explain how you can decide on how to partition your table, is giving me very, very good results. So I've had a company that does reporting for restaurants, just basically gets logs from restaurants, log files, and gives a report. And I do a health check once every 6 to 9 months. So the first time I did partitioning, it improved it from 90 minutes to 5 minutes. Some query that they send in an email, so it's not, they were very happy with it. The second time I did sub-partitioning, improved it again. So I get very good results, but so it's a big topic. But usually, so I'll explain what partitioning does now. So you have a big table, and this is your columns and your rows, and it's just one big table. And you remember when I showed you the index movie? So remember, really lots of layers, sorted in every place. If you want something, you have to go down all those layers till you find the data that you want, right? And what partitioning does is basically breaks this table down into many individual tables, but you have an algorithm head of this table to direct it to which partition. Imagine this is a table on its own, and you just have an algorithm to go to the right table, right partition. Nod your head if you think you understand. Excellent. Right, Sergey, this is your mind map. I'm going to explain all this. This is just like for the PDF, so you can see it, but I will explain every part. So you have, in the partitioning, you have use cases, how to do partitioning, automatic or manual, the benefits and use cases, and issues that you have, because you do have issues with it. So with partitioning, the use cases, basically you have two use cases, and MySQL only uses one of those, and that is to reduce the data that you access. So you're thinking about a much smaller table, or hope you get a much smaller table. Partition doesn't always work, as always is available for you, but when it does, it can reduce the data that you have to go through. The second option that bigger companies use to crunch big data is to parallelize the data. That means, with reducing data, you're supposed to only get one partition from the whole table. You want to avoid the rest of the data. With companies that try to crunch like a lot of data, they equally send the data to different partitions, and then they ask each partition in a separate thread to process that table, like Hadoop basically. Process that table and give you the result. So the opposite is, you still want to partition, but you want to partition it and use every single one together. Okay, but MySQL is reducing data. The benefits obviously are, I said, short table scan and less levels of the index, like I showed with the movie again. So yeah, faster to get the data, faster to write it. It depends. There are some issues, and I'll go through them. But yeah. So the issues are basically the algorithm that you find the right partition to go to. So with inserts, according to MySQL Performance blog, MySQL Performance, High Performance MySQL 3rd edition, when you insert something into a partition table, it locks the whole table, it gives you the right partition, then unlocks it. I think this is in 5.5, and I think in 5.6 there are less locking with this particular example. But yes, it does lock the whole table, give you the right table, then unlocks the whole thing. It appeals to me that sometimes that's still an acceptable overhead, because it just writes it a lot faster, or like when you write it, you don't have to like reconfigure the B-tree index or sort it in a different part of the hard disk or whatnot. So it does appear that it's still, in some cases, still an okay overhead. And select, when you partition something, if you do a select statement with a column in the where that isn't using the partitions. Let me explain. So if you're partitioning by date, and you're doing a search on this partition table, and you're not using date, you will search sequentially each table. That actually may be slower than just having it unpartitioned, just regular table. So it's very important that when you decide how to partition the table, it's important to work along the lines of how you use that table, like the queries that access that table. A few more issues: you can't use foreign keys with partition tables at all. You can't have a primary key and a unique key as well, because it can't guarantee the uniqueness. It can only guarantee on primary key. You can have like a unique key and no primary key, but not really the point. And you also have a primary key overhead. I'll show you why, because you have to kind of like add the second. Sometimes, let's say you have ID and you want to add the second column in there to the primary key, so that you can partition on this new column. So you're adding to the table size, and you're adding to each index, because each index will get the primary key from each index will have the primary key appended to it. It will grow in size. And I'll give some examples of the previous thing I just said. So partition types, you have range, list, hash, key, columns, and sub-partitioning. I'll explain that. So range, basically, you define the range. Usually it's something goes like, if it's less than this, fine. If it's less than this, so it should be, so the less, so less than this should be like less than 1, so it's 0, and the second version would be like 10, so it's 1 to 10. The next one is 20, and then max is 20 and over 21 and over. Very convenient with dates, and I actually have an example with dates. List is a hard list, so you define a list of what you want. If it's not the list, you can't insert it. If you insert something and something else, it will just give you an error. Hash, so key should be above hash. So key is just like, a random, you give it a column, let's say customer ID, it will do it on its own. And hash is the same as key, but you wrap it with some kind of function. Like, so a very common thing is to do 2 days, 2 underscore days to date, and then you can work that out. Again, I will give an example. Columns, I haven't used columns at all. I've experimented with it, so it's a combination of 2 columns, maybe more, I'm not sure. I think it's 2 columns, where you have like a range and a list. And I just haven't really got it to work very well. Sub-partitioning I have gotten to work very well, and that has helped me. So basically, sub-partitioning is a range or a list. That's one of the partition, and so it's 2. It's like a partition and a sub-partition. The first part has to be either a range or a list, and the second part either has to be a hash or a key. So, good example of this would be, range by date. So I want from 2012. I want each month to a particular date, and then max over this. And I also, and the sub-partition could be the customer ID. Hash it on your own. Don't involve me. And I'll say like, I want there to be like 10 partitions for dates, and within those dates I want there to be like to break the customer ID into 10, so to be 100 partitions. To me, it works quite well. It depends on your use case. I remembered something from the issues. I forgot now. Oh right, so the algorithm here, if you have a very, very long range, like let's say you have dates, but you do every month till 2023. So the longer, this is an algorithm really, it's like every time you insert or select a table, it has to go over this whole script that you've just written, like less than this, more than this. Let's say you have like 30 lines to do the range. If it's very long, it will increase the complexity of the algorithm, will be slow. So try to keep it like, shorter than you would have. And then every once in a while, maybe just alter table and redo the partitions. Right, okay, so this is automatic. So usually, like, ID, the popular reasons is ID, customer ID, country ID. Time is very popular, or hash some thing. I'll give you an example now. So that was really bad, really, that example. Right, so when I partition a table, I use the query digest, but you may not notice, but these queries are filtered for one table, an orders table, and I'll explain how to do that later. But this helps me know how the application uses this table and only this table. There is no other tables here at all. Just the orders table, because I want to see if I want to partition the orders table. And so here, for example, the first one, it's 26.3% of the overall usage of this table. It uses a date, and that's marked with a color. In the second one, also uses a date, and in the third one, uses ID, and the fourth one as well. But you can see that the third and fourth one are like together. They're like 8.8% exactly, actually. Right. So I can make a decision. Right. I can make a decision to partition the table by date, knowing that I may slow these two down. But that may be okay, because the first two queries will be faster. However, I have done something that I did that, and then the third and fourth one became the slowest one. So I'll show you how you can find that out. So what you can do for this example is you can So you can create orders. So you have your two variables, and I just not included the rest. You have int. So you have ID, and then you have date, and you can have two ways of doing this. You either include the date before the ID. So again, you need the column you want to partition to be in the primary key, and you still need to be unique. So in a lot of cases, you keep the ID just to make it unique, to keep it going unique. And there are two ways to do this in this example. If you put the date ahead of the ID, the benefits are that you can use the date now in your other indexes. When you save the data to disk, it will be sorted by date. So if you want to search by date, it will be fast because it's sorted on disk that way. But if you do that, you have to include ID has to be first. You have to include the ID in its own index. So you're adding another index, which just adds overhead because it's an auto increment. You have to add an ID, another key. And for all the other indexes will be a bit larger now. And you can also do ID and date, and then the second one date. And what will happen is it will just send you to the right partition. If you have a date question, it will send you to the right partition, with the date range that you, and then you can search it again by the index. The thing is here, for example, if you to make these two statements use this index or any one of these, use that index, sorry, you have to increase and date equals something, so it will know which, it will get to the right partition. Otherwise it will just do over the whole table until it finds it. Right, so this is an example of how you can do that. I don't think you can see this, but this is 2_days date. So you range it, and then you do partition, you get the partition name, pmin, less than, you don't have to do it like, from 0, but you can do less than 2 days, sorry. This will give you like a number. Less than the 1st of this year, and then like I do like, half year, and then like I do like, because I'm not interested really in that date anymore, then I do like 1 month, and then I do max after some date that I'm sure I won't reach, just to have safety. So this is popular. There is a thing that I haven't really. Okay, so I've explained that if you partition on something on a column that isn't used very often, and that isn't used very often in your queries, and you just make it a lot longer. So I have seen cases where people do this exact thing just for maintenance reasons, because they do it like 1 month of the year, and let's say they keep 13 months and they drop off the last month. But almost none of the queries that use that table have date inside them. So they use this for maintenance to make it easier to drop partitions and delete old data. But it slows down all the other queries. So it's very important when you do this, you reference how this table is being used to decide how to partition it. Another form of manual partitioning that I have seen, so archive, basically you have your main table, which can keep 30 days, 90 days worth of data, and then you have the same table but with archive at the end or the beginning, and you yourself move data into it, and you tell yourselves or the developer friends to either do a union if you need both tables, or when you need both tables do a union, but usually you just use the one table. I have seen things where you have like time, so you would create a table _ 2012-01, 2012-02, you can do that. Or you can kind of like shard it, which basically means like you do it per country. So let's say in America you do East Coast and West Coast. Same table name, one will be East Coast, one will be West Coast, and you tell the application where to go to get the data depending on which part it is. Or like, North America, Europe, by continent. It's kind of like partitioning your data. With this manual you can keep foreign keys if that's what you need to do. Okay, so I have to have a cat at some point. So really with partitioning I've seen a lot of good usages. Has anyone here experimented with partitioning at all? Interested in partitioning? Yeah? Okay. It depends really on the table and what you need to do with it. And yeah, sometimes I can't use it, sometimes the queries don't let me, or I see there's no like real good way of using it, or there are foreign keys, or it really depends. But in other cases where big reporting queries, particularly big reporting queries, I've seen a very big benefit with partitioning. Do you want some? I know it's after lunch and everyone's like really full and tired. I hope that. I can always go back, and if you have a particular question about something, let me know. So we've done indexes, right? We've done just a splatter of bottlenecks, which you just write it down somewhere. Doesn't.
Just ask one thing.
Yeah.
Well, when you do a range query
yes.
on a table, obviously it doesn't have any indexes, right? But when you when you can go back to the partition that you did. Yeah, go forward.
This one?
No, where it actually shows. Yeah.
Okay.
Exactly. Well, you kind of use the ranges in there as well, right? Doesn't that slow down the query?
What do you mean?
Well, over here.
Yeah.
Uh,
The fact that I added that additional algorithm to separate it by range, you mean?
well, either that one or all the others. I mean, do you, when you do,
Well, in this particular case, this table is broken down into 3 partitions. Everything before 2012, the first half year, and let's say the second half year. So if you needed like information from one of those partitions, you'd need to specify date. We'll bring you to the right partition, and you would go to that table. Do you mean the algorithm that is causing?
well, when you try to show some data, right, from within some range, I don't know how MySQL does the search, or do you have to hit partition from? Do you mean that you have to hit the proper partition from your application directly?
No, you can do that in 5.6, but in this example, all you need to do is have date in your query, like where date equals something, and it will figure out which. You can send it to 2 partitions.
That's exactly my question. I mean,
Yeah.
if I do that,
Yes.
I mean, then if it's trying to look through the partitions, which one has the data?
Yes.
Isn't that way too slow? I mean, wouldn't it be faster if you had partition which has values for date equals 2012?
So.
I mean, 2012 0101, rather than having any less than 2000.
So I understand your question. So what it would do is it would first determine which partitions to go to by an algorithm. So you're not referencing any data at the moment. You're just doing an algorithm. So if you would say, and it will use basically this algorithm right here is an algorithm to it. And it will say if you're looking for, I need all the information between 2011-01 to 2012-03, it will tell you that you need these 2 partitions, give them to you. You will search them sequentially, meaning you will get the data from the first, finish, get the data from the second, finish, present it. Okay? And this algorithm doesn't reference data, it just references the algorithm at that stage. And then it tells you which partition you want, and then sends you to the data. Okay, so I have to say that this section is a bit difficult. So after this, it gets like a lot more like me talking and just showing diagrams. But this is like a bit more full on. But I think it's very, very important. It's something that basically I've developed with the help of Stefan to some degree as well. Something I've developed, and I find it very, very useful to improve performance or just prevent problems. And it's something I call intensive table optimization. I don't know has anyone actually done this thing with me last year, because I was in Percona live last year on this topic. Probably not, never mind. So I spoke there about all these like lean methodologies, and like you have agile for development, but lean is more database oriented because you have like a lot of numbers to go through, and you can see exactly like how databases are performing, and this cache is used, this isn't, the spikes on the I/O, and it's much more like lean in a sense. So in the spirit of lean and not wasting and reducing waste, I developed this kind of approach. So basically, once upon a time, I was researching a way to make a database working set fit as much as possible into memory. And the reason for this is this wonderful diagram by Percona, by Vadim. And it does a comparison. Basically, the article was trying to answer a question: should I get a solid state drive, RAID 10 or Fusion IO? This is quite old. This is like in 2010. Okay, and the parameters is that the working set, or the entire data set for his example was 18 gigabytes, and here down here you have the gigabytes allocated for memory. Okay, the buffer pool. So starting at 2 gigabytes to 22. Okay, and what it shows you is that if your working set in memory, it doesn't really matter what kind of I/O speed you have if it all fits in memory. So you can see like at 20 gigabytes, which is slightly more than 18 in this case, everything is very, very fast. Right? So you can see like, the lines, Fusion IOs, when it's, 2 gigabytes, it's very fast. It's 5 times faster than RAID 10, and RAID 10 and Intel SSD is twice as fast as RAID 10. But when it all fits in memory, these things just work out faster. And the reverse is also true. When everything works very fast and all of a sudden things are slow, this may be the reason. Like you just slightly gone over like this peak, and things work a lot less fast, and you need like a faster I/O or something like that. So the point was to reduce the working set at least, or not your whole database, but what you use within your database, the working set of data within your database, or to reduce its size. So what I learned from this is basically people are usually very liberal with the data type sizes. So even with the client I'm working at the moment, the developers, when they develop the schema, everything, all the IDs are big int, and there's lots of foreign keys. So they didn't know like how high it would go. So everything is big int, and even things like country, currency, things like that. And it just, if you have like 400 million rows, then it starts to increase the size of the overall data. There were usually so many indexes that they multiplied the table size, so the indexes literally were bigger than the actual data, and I call this the PHP MyAdmin effect, which is basically you go tick, 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 tick to all the indexes. Who's laughing? You? Okay. So tick, tick, tick to all the indexes, and it starts becoming very big. And also the indexes were not efficient compared to how the table is used. So it is important, and I hope I've explained this, that you have the relational schema for your data. You have the indexes for how you use your data. And if your application uses it differently a month from now in the next release, you have to change your indexes. It's not the same. Like data and indexes are not the same. And I think if I'm not mistaken, when relation database was thought up of, they didn't have indexes at all. It came later just to speed up the searching. And there were so many indexes that they confused the optimizer, hence optimizer hints, and things of that nature. I also discovered partitions were not used when they could have, or misused. So the example of just having partitions for maintenance reasons, not for reasons of accelerating your SQL queries. I discovered sub-partitions and primary key alignment, and I also discovered MDB compression, but I didn't get very good results with it at the moment. 5.6, I think that's changed, but yeah. So there are all sorts of these tools to help us, really very, very nice tools, mainly from the Percona toolkit. And I think like even if you watch like the webinar I recommend, they say use this tool, but it's a very wide-reaching tool, and it has a lot of like specific settings. Even the query digest tool, which is very, very useful, does have like a lot of filter options, group by options, and no one really teaches that. So you had this thing where like you had complicated Perl scripts, and this is a football player from America. You had like a complicated Perl scripts, and they were just said go use them, but no real direction of how to use them efficiently to solve your problem, or like it was so complicated that you didn't really know how to go about it. So I spent time learning these tools, and I came up with this way called intensive table optimization. So I think you should just get the PDF, watch it there, because this is a bit very, very bright. This is broken down in two parts, and I'll explain why. So me as a consultant going to your database, I want to get like just the same way that I chose to get the best, the worst query, and let's say it's 54% of your server capacity, and you make that much, much lower, then you've improved server capacity. I wanted to find the tables that attracted these bad queries. Like overall, these tables get the sum total of the queries with this table that are connected to this table are what's causing all the bottlenecks. So this table is slow. How do I find out these bottleneck tables? And even with the query digest, if you have a slow query at the very top, and you add an index to a table to make that faster, What's to say that you shouldn't remove another index? What's to say that just adding another index and then you do it, 3 months time with a new release, you add another index and another index. There's nothing, there is, sorry, but it's not like a clear thing. Should I remove another index? Should I just merge these two indexes, instead of two separate indexes with one column to one index with two columns? Because you just address the top query, you're not addressing the table as a unit. So the first part is how I find the bottleneck tables, and you don't have to do it because I may not know your system if I come to your company and try, but you may, and you may know which table is the worst table, so you may not need to do it, but I'll tell you what I do and why I do it and what information it gives me. And then, once you identify the bottleneck table or tables, you do the optimization that I'll explain. So again, gathering data, we again use the MySQL slow log, set it to 0 or the micro slow patch. By the way, the micro slow patch has more information, from InnoDB and Prof, but I don't use it very often. Or if you add this information, it will increase. If you set it to add this information, it will increase the size of the slow log. But yeah, so I just use the micro slow by micro slow with the default data. You get this kind of slow log for 6 to 24 hours, 24 hours. Hopefully it's a good indication. I hope that within 24 hours it covers all the queries, and you won't have some queries that I'll run once a week or once every 3 days and you just miss them. But let's pretend that it covers all the queries. And it's also helpful for this, in addition, it's helpful to use the Percona MariaDB user statistics patch, which was from Google. And that patch gives you information about how tables are used in terms of how many rows are read and written to that table, which indexes are used in terms of how many rows in that indexes are read and written to. And it will also give you a list of completely unused queries that originally back in the day you used them, but now the application the database usage has changed. You don't use them anymore, and you should remove them because they're an overhead. And there's also, in addition, not to do with the user statistics patch, but there's a query that you can run to get the largest tables. So I particularly use the largest tables because I try to shrink the database size of the largest table is very helpful. And this is the data that I gathered. Let's see the data. So this is again, our Drupal friends. This is the query, but here I've removed the admin and set thing. This is just SQL queries, select or update, insert, delete, and I may decide to go with DP users as my bottleneck tables just from this. Because they told me DP users is the worst one, 27%. I may focus on that. I may not. I may choose the second one afterwards. It depends. So the table statistics, you can see here that I showed you an example of table of rows read. So this sometimes when you do a query, it gives you back one row and you read one row, and sometimes you read a bulky query which gives you back 100,000 rows, or it gives you 100,000 rows from the hard disk, but then you filter it, it still gives you 100,000 rows. So DP users also here is very, very high rows read, and it's in the information schema. I use table statistics. It also gives you rows change, and a very nice thing, rows change times indexes. So if you have 3 indexes, the rows change will be that times 3, and it just gives you some perspective as to how much data has to change whenever you insert one row. Now, what I do here is a function that's not very much discussed, I think, or I do need this for this particular example. So I go to the slow log and I do group by table. So forget all the SQL. I group by the tables to see the overall response time for that particular table. Here in this example, advertisement is a very small table, less than 32,000 rows. It's used as a descriptive table. You get an ID and you get a description from the table, but it shows up in almost every reporting query, and it makes it seem here like it's the world's slowest table. But because this isn't the only information I'm basing my work on, then it's just then I can understand that this isn't the world's table. There's not much to optimize in this table. It's very small. Table sizes, so very, very useful for what I was doing. So The query is down here, originally from MySQL Performance Blog. So for example, total daily summary, you can see 610 million rows, and the data is 77 gigabytes, but the index size is 88 gigabytes. Together it's 165. So, and you know, the index fraction, you know, is that it's over one. It's over one. Like the indexes are larger than the data. So in the second one, you know, the data is a lot higher than the index. It's not so bad, and in terms of like the fraction between them. And the last one is basically just messages. You don't have that many indexes, so it's relatively optimized from my point of view. Like the indexes that are there are fine. It doesn't have too many indexes, and it can fit in memory better. In other ways, so you have like these three things, and if you combine these three things, you get a magical graph. Goes like this, and this is what I've done. You don't really have to do this; it's just for my own entertainment, really. So here is the rows examined by the user statistics tables. Here is the response time from the query digest, and the size of the thing is the size of the table. Like the bigger the planet, the bigger the table. And you can see that these two tables at the top, and even these two, but more importantly, those two tables are bottleneck tables. They're not very big, and you can see here. In my example, the table is very big, and there is a funny story with this. I was working with a client, and he had like another guy who is American in this room, because I'm gonna say something slightly bad about Americans. No, okay. So he was American. He was very confident, and like said to me, and he's like, he goes to me and he does some kind of a quick query, like I've done with the table sizes, and he says this table is really bad. It's the bigger one. It's really bad. It's you shouldn't be writing so much data. You're slowing everything down. We need to optimize it right away. And I said this, but this is something to do with, I think, log. It's in Drupal again. It's something to do with admin messages. It just logs it. It doesn't even reference it. It just like logs it. And I said this table, it's very loud, but it isn't used very often. It's just like record stuff and archive stuff. And with much more better use of our time to optimize that table up there, right? But the guy was spoke more confidently than me and persuaded the client that I should optimize that, and it was just a waste of time and money. So the table targeting, basically you're trying to get the most worthy table to focus your attention on, so like biggest bang for your buck. Honestly, I have to say that with this kind of technique, the best results I got is if I use partition, and if I don't, then I don't have really slow queries. Like it's this kind of situation where if it's not broken, no one notices anything. Like everyone, it always works, but no one pays any attention because it doesn't break. So it kind of like the table works fine. It doesn't work super fast, but no one complains about it either. So if you know which table is the most troublesome because you work in your own company and you may know it better than me, you don't need to do the investigation. You do need a slow log for the second part, but these investigations may help you understand DB usage better. So you can make the funky graph that I did here, or the cool graph, sorry. You don't have to. But the next part is the part. So basically in the optimization, what we have is we try to make sure the data types are accurate to what is used, and there's a function for that. We evaluate if we need compression, and then we go to the query logs, which is a slow query log, and when we digested it, and see which indexes are used, which indexes are not used. If I can partition, if I can sub-partition, if I have foreign keys, then I cannot maybe remove the indexes or add partitions because foreign keys may block that. But at least I have an understanding of the table. So the data type. So I just use procedure analyze. You do select star from table procedure. You can do like 1-1. You don't have to do 100-100. You do 1-1, and it will in a lot of cases give you good advice. I'll give an example. So you have here, in a case where I used tiny int instead of a big int, so it was the row and then it had an index for that column as well. So the row was reduced by 7 bytes because big int is 8 bytes and tiny int is 1 byte. So I reduced the row size by 7 bytes and the index also by 7 bytes. Times 350 million rows, the table is 4.9 gigabytes less. So just that makes the table less, fits in memory, can be searched faster, and all that. I would also, the procedure analyst may recommend enums instead of vouchers, consider that. Maybe you may not want to, so in most cases you wouldn't want to, but consider it anyway. And try to remove nulls when they're not needed, so it will tell you if you have nulls in the column, this tool, the output of it, and if you have nulls, don't change it. If you don't have any nulls, consider removing the default null thing from the statement, because it's another byte, and database servers don't like nulls, confuses, that's a long conversation, just take my word for it. Compression, so compression usually is best used for tables with either lots of voucher or text. It compresses by multiples of 248, 16. What I do is I experiment. I put InnoDB strict equals on, and then I try to compress the table in like a dev environment, and so I try to like by 2, fine. Then I try hull shell conditions till I get to something where it gives me an error, and I go to the one before that was fine. And on my tests, it's always very, very slow when I set compression on table. Like alter table is very, very slow. Insert, updates, and deletes are very slow. So if it's like a table that's rarely used, go for it. If you actively use it, I don't know. Like it depends. Try it. I haven't gotten good results for it, and I'll go back to it in 5.6 and see how it goes. So the next part. Oh, this is. You can read that, can't you? Yeah. So the next part. Well, this is the second part. So with query logs, and I'll explain what it is. You gather the data that we spoke about. You get the slow log, and you get the query digest, and then in this case you filter by the target table. So I'll show you in a second. Then what you do is you remember the partition when I showed you the filtered by table thing, how this one table is used. So it's that. Then you make an assumption, because you're making an assumption it may not work. You think that if you add this index, if you partition on this column, it will work, but you're not 100% sure. Even me, so I test it out. So you make an assumption. You have a test environment, which you can't see here, but this is test environment, and you test your assumption. You use some other tools to see if it's right. If you get new results from the new tables that you've created with your assumptions. And you see if it's faster, if the queries are faster from what you got before. And then, at the end, you deploy it. So, you gather the data, you make an assumption, you test the assumption. It can be a few times till you get the right one. And then you deploy it. And I'll explain all these steps, so don't worry about it. So the target table processing. So you have the table that you want, and what you want to do is you want to take the very large slow log of 24-hour period, and you want to only filter it on the table that you want. So I said I want to filter it in DP users. And what this whole query does is it goes through the slow log, 24-hour slow log that we had, with all the many queries. Pretend it's like 30 gigabytes, and it filters only queries that contain DP users space. So, like I try to get it like for that table. If your table has a very common name that may wind up in other queries, and it's a problem. When you do no report or no print, it just basically outputs that the information from the slow log, those queries with the date and how long, with the time and how long it took, into another log, and we call it DP users log. So this new log is only only queries that are relevant to this table, and this is important. You need this particular filtering stage for several other stages in what's going to happen in the future. Then you you run the regular PT query digest on this new log. You don't have to do this is like limit 100%. What this means is you show every single query. By default, it will only show you like 95%. The worst one, then it will do miscellaneous. You don't really need this, but you can if you want to. Then you output it to another text, and then you get the same table that I showed you. You get this kind of information, but just to remind you, this was the table that I showed you with the date and the orders for the partition. So you get that information. So here we have DP users. We have I'll just run it through with you again. This is like a part of what the query digest will give you. The query digest will be much more verbose, but I'm trying to like prevent that verbosity and just give you what you need right now. So the first query, 10.7% of the overall table usage. Update DP users. So obviously you're setting some kind of access, maybe times. I think it's timestamp. Well, UID. Well, the user is this. So the UID may be the primary key. I hope it is in this case. I think it is. So UID. So this is the primary key update, and it happens a lot of times. There may not be much you can do about this. So it's primary key. It's primary key. I think I removed some indexes because this will also give you, like, if this table was referenced in a table with many joins, but this table wasn't really the determining table that was in that join, so I just removed that. You can do it by explain. So the second one, select access, so the same as above really. Again, primary key. And the third one, which is 7.1%, you have status equals 1 with an order by. That you can probably do something about. Even maybe a three-star index. I do not see like I'm not sure if I can partition it. If you would partition it, would be on UUID, but then you would miss out on that. So I'm not entirely sure if partitioning it would be a good idea on this particular table. But let's see. So you have the fifth one. It's becoming less and less now. Fifth one, you have name equals status and picture equals nothing. Status created. You can include picture. Created is range here. You have a join here, but I don't think the DP users table, again, because I've already done this, is the culprit here anyway. Then you have name, password, and status. So you have a few things that you can see, or you can just visually see. You have name and status. You have UUID, which is obviously the most influential here. Name, status, and created by. So you can already start thinking about how to build your table from like the index point of view. I don't recommend partitions for this one. If you would, no, I'm not sure if I would actually. It may not be actually that big, this table anyway, but obviously this table is written to quite a bit, and you can get a sense for it. It's written to you're updating the access time of the users very, very often, and yeah. So I'm just going over quickly, but I'm hoping that I broke the information down enough. Like I've given you only the table, I've given you only the information from the query digest, and I've highlighted these areas, and I'm hoping that it's manageable chunks for you to start guessing which indexes I need, partitioning or non-partitioning, and things of that nature. Another example here that I've already gone through, it was the orders table and date and ID. So we already discussed this really, but you can partition on date, you can rewrite the IDs to include date maybe, or you can do ID and date. You have some options, but at least this information is visual in front of you. This is all information. It's not hidden anywhere else. This is here. Okay. So testing assumptions, basically you go to your testing environment, and what I do is I create DP underscore users. So this doesn't tell you much, but I create DP underscore users too, and let's say I added an index to help this particular query, and I want to see if it works. So I still have the old table on my environment, and I still have with all the updated data, or updated like as much as I can. So I have the right, as it resembles live environment as much as I can, not just 200 sample rows. And then I see like if my theories work. Sometimes it works. Sometimes this will be fast, but something else will be slow. So you have to check you basically have to go over all the queries that you had in these two things and see, have I made something slower? Have I made something faster? But you have that reference to go to. So basically to set up the test environment, ideally you want hardware similar to live. This can be like your own environment, or it can be a slave that isn't very important. Because if you're creating like a second table, maybe no one will notice, but you may kill replication, so be careful. Data size similar to live environment. I've spoke about that. Replication slave cannot. Okay, so this is actually someone like Ben here from Pythian said actually this can be changed. So what I've understood that if you have mixed or row based replication, so mixed is default on 5.1, you can say specifically statement. But if you have row or mixed, and the data types is different, so if you want to change the data types to a slave that's replicating data, let's say DP user, and you want to see if instead of big int you can put tiny int, okay, and see if that like the benefits of that. But if you're still replicating to that table and it's row based, it will say, look, the data type isn't the same, error. But Ben at Pitting said that you can add a setting to your MySQL file that allows it anyway. But normally that would be a problem. Then you can create table 2 and run results against it. You have all this time to go over basically 4 or 5 queries and see if it works better on the assumption that you made on that table. You can also, if the data is too big or you just want to test certain tables, there's a ways you can set up a test environment where you won't have all the table sizes on the live environment, but you have the last 30 days, the last 90 days of the biggest tables, and the rest will be fine. So here you have MySQL dump, and there's a minus well clause here, and then you say just for these 2 tables, well date now minus interval 30 days, so the last 30 days, output it to dump.sql, and then the next one you just do the rest when you ignore these 2 tables and you append it to the dump.sql, and then you can set up a test environment that's not 100% accurate, but it will probably take up less space if you don't have as much space as it has on live. So that's a few ways that you can do that. Right, okay, so we had the dpusers.log, which was the filter thing, and then we have this nice tool called pt index usage, which basically, it's very, very useful, but it's a tiny bit buggy, in that when I've used it recklessly, it basically so it takes, what it does is it takes the slow queries in the slow log and runs an explain statement. It takes this log with explain at the beginning, runs it against the server, and then see which index it chose to use, and then it will tell you at the end for all your database that these indexes are never used in that 24-hour period that you had, and you can delete them. Including indexes which are duplicates. So some index, I haven't spoken about this, but some indexes, like let's say are column A and column AB. So index on column A and index on column AB. So the second index will make the first index redundant or duplicate. So this will usually covers also duplicate indexes. The problem is that it opens up all the tables, and if it does it almost all. A few times it brought down the database server because either it opened too many tables or it was too much. So what I've done, or what I've learned to work with this tool, is that I've filtered the log to only use this table. So I already have a subset of the data, not to kill my database. And then I tell it, only choose this table as a secondary precaution, and then go over recommendations. Sometimes it happened where I made a change of the index, and now it says, because this new index that you've added, you don't need this. This index is now unused. Like, it doesn't show up in this. Fantastic, I don't need it anymore. So this tool gives you that extra level of final tweaking, and it is quite useful, but with caution use it, and use it in this way that I've discovered is relatively safe and gives you good advice. Okay. So deploying strategies. I do want to give you this so you're not afraid to make changes to tables. Do not be afraid to add an index. Do not be afraid to partition. There are these strategies that help you do that, so that it's not like, oh, I don't want to do that. I may bring down the database server. Maybe I can just make a change in code. Maybe I can just move to NoSQL. It's like these are the ways, or the strategies of doing. So the first one is rolling servers. Well, let's pretend you have a master. Never mind. You have 2 servers, sorry, and you have the traffic to one server, and you stop the traffic to the other, and you make the changes on this server. This doesn't have any traffic. You make the changes to this server, finish the changes, and you put the traffic back to this server, and make sure it replicates back. Take this server off, you block the traffic from this server, and then you make a change and you put them back in. Okay, so rolling servers. One server has it, one server is offline, and then they switch. The second one is PT Online Schema Change. This is a very, very good tool. Originally from Facebook. Percona used it. Percona made it within the tools. Very, very good. The only problem I have is that it can only take if the primary key is one column, and as I've shown you with partitioning that and if I use, for partitioning I need 2 columns, let's say, then this tool already, I can't use it anymore. It's still a very, very good tool. If you want to add remove indexes to this, basically what it does is it creates a new table that you don't reference it. It puts triggers on the old table to keep updating the new table if new rows come in. Dumps all the data to the new table and then quickly renames the table, drops the old table, depends if you want to drop it, renames it online. Obviously some I/O, but you may not need any downtime. Another way is a 2-part move. So you can see this is in terms of downtime. The first one, you won't have any downtime. The second one, maybe slightly I/O intensive. The third one is a 2-part move where you create a new table, table 2 of the table you want to change. You make a calculation and you say this table will not, anything older than 30 days will definitely not be changed. It's just too old, will definitely not be changed. So you move all the data from table 1 to table 2. Well, the data is older than 30 days from today. Then you have downtime. Then you remove the remaining 30 days into the new table, and you rename the tables. And you do insert ignore if something has changed, or replace it if something has changed. Usually insert ignore it. And the last one is alter table, proper downtime alter table. With MySQL 5.6, they may do online. This may all be useless in 5.6 if they do online, but I think Shlomi, one of the people who has a blog, speaks in the MySQL community, said he tested it and he said this does not work yet, and MySQL 5.6 is not released yet. It's just a testing. It's more than beta, but not released yet either. So maybe if you have this will be all online, kind of like the option 2. So you may not need, but really, I'd like you to feel confident about deploying these changes, because you really do need to adjust your tables to how you are using it. And again, each release of your application may use it slightly different. And I have this thing with the current kind that I work. Every release, someone throws it this really long query. I think I got everything nailed down. And then the new release comes in, this really long query, reaches the top of my query digest. Where did this come from? Sometimes I can fix it, sometimes it gets a bit complicated. Right, so keep trying keep learning, keep trying new things on your test environment. Have a test environment. It will increase your confidence. I haven't given you everything whatsoever, really. I've given you a certain percentage of all the information that's out there. Someone here pointed out that maybe an index may be used differently than what I've said. But what I really hope is that you pick up from the theory and test it on your environment, and then if you discover something new, or something new came out on 5.6, or someone blogged about it, then you can just test it in your environment and see if it works for your particular needs. And you don't have to deploy it live right away. It shouldn't be scary. It's your developers, so technically you can leave a long alter table statement running for a day, come back to it tomorrow and see if the query is 3 times faster. So just have this test environment, or try to get your managers to, or if you are the manager, have this test environment and try things out. Just learn by doing. Right, so just going over things again. I hope you have it in front of you, the PDF, because this is really bright. Once we know the target table, you may already know it, so we gather the data in a slow log, we query digest it, we filter it by table, we make an assumption, we test our assumption, with the explain from the query digest, from the worst queries. We do index usage from the slow log to see if some indexes are not used anymore. We get new results and we deploy them. Okay, so part 3. So doing okay for time. So this is just me talking, just theoretical and fun, and it's kind of interesting. So we have the first thing we have is read cache. So this is basically kind of to save on reads, and this bottom part you can't really see, but this is inside the database, and the top part is outside the database. The page cache, you will probably know better than I would. Query cache I'll talk about, and all these other things. So again, so we have outside the database page cache, query cache. Inside the database we have column cache and summary tables, which I'll explain. And there's some degree of complexity to implementing like some of these, but I'll go over that as well. So page cache, I'm basically talking about three things. You have browser cache, which you are telling the users who have a browser to just not ask the server for new information. Like the whole page is saved on your browser, don't go to the server. You have things like reverse proxy, so Squid, Varnish, Nginx, Apache with the thing, or proprietary, which basically like save the whole page, the complete page, and you don't have to render it, you don't have to go to the database, it's saved. Then you have like full, or I call it file, but it's like full page cache in the sense like a lot of like PHP kind of things have it. So like WordPress, Drupal, they have Zen to some degree, and they have this thing where basically you save the whole page somewhere as an HTML file on the hard disk of the server, and until it needs to be invalidated, that's the way it is. You kind of know what I mean, right? Like with WordPress, you can save the whole page. Just imagine, you don't need to go to the database and render it. It saves everything as one HTML file, and the fastest way is just get it from a file from disk. Anyone familiar with this kind of? Yes, excellent. Reverse proxy is new to you guys, or did you guys know about it already? Nginx, Varnish, yeah, some people know it, some will not, but you can, research this in your own time. Again, this is completely for you guys. You guys, a lot of you may probably know this better than I would. The problem is with this full page cache is you have this issue. You have an issue with stale data, and sometimes it's very, very annoying. Like I think you guys know, like I made a change to the website. Like you want to see if it works, but like you reload the website, but it's still the same old data. Like flush the cache, yeah, okay. Not very exciting, but I guess depends. He looks excited. Right, so query cache. So ultimately, I'm thinking memcached here from your point of view, but there's a few things here. So there are three that I see. I think even though it's three, I think the 95% or 99% is volatile from your point of view. So consider the volatile as the most important. Volatile basically means like memcache, Redis, Hibernate cache, even arrays in your own application, where you basically request it from let's say memcache. Does it exist? No. Go to the database, place it in memcache, and then next time it exists. And in memcache you give it like a time to live of, let's say, 30 seconds, 5 minutes, depending. It's somewhat stale, but you're okay with that. And then like after the time to live expires, it expires. With these kinds of things, there's a problem with cache stampede, which means basically it's not like a massive problem, but it's definitely there, where you have one person requests, so it's not in memcache, and then 20 threads request this database query to update memcache at the same time, and they kind of hit the database at the same time and cause a cache stampede, because it's not in the cache, so it's not in memcache. So you have that. So streaming. Think of the example I give you for streaming is that you have your memcached, but you have a cron job. Let's say you have a select count star from table, and you only care about every 30 seconds. So you have a cron job on your server that's separate from the request from the website, and you update the memcached row or whatnot, key value, with the count of this table, because that's what you want. You want it ahead of time, and you've set it up, but it's streaming in an interval with a common query. So you will never really request it from the website. It will just be there. Sorry, you won't request for it to be created from the website. It will just be there, and you can set up a script that when the database crashes, like when it loads up, to feed it, or maybe to give it anyway because it's every 30 seconds. And that's something called streaming. So if you know the common queries that you have, you can place them in your volatile cache, and it's asynchronous. It's you don't have the issue of caching stampede. You may still have the issue of stale data. Yeah, and the last one is the last one that I have the least respect for. Sorry. It's something called I've encountered like with some people. It's called the shield. It's called a lot of times with MongoDB. So it's called the Mongo shield. This isn't the name I invented at all. I just got it from a client. which basically is they didn't know how to optimize a particular table, so they kept the whole table in MongoDB, or they wanted an aggregate and they kept the aggregate in MongoDB. Although for the aggregation in particular, a relation database is much better for that, and I'll show you an example why. And just so you know, regarding group bys and aggregates, relation databases are still extremely fast, to some degree faster than, let's say, it's faster than Hadoop, and I'll explain what I mean. So it's faster than like these Hadoop methods, but it's like with one thread. So with Hadoop or with like your MongoDB, only when it reaches like over a certain point, like let's say over 30 minutes, over 15 minutes, then you would like to use Hadoop. But on its own, select group by into table, it's very, very fast from a relational database point of view. So only like in a particular point, cutoff point, then you say, okay, I want these things that can break it down into many threads and whatnot. With this Mongo Shield, if you keep the whole table, let's say I don't know how to optimize the table, I heard MongoDB is really good. You put it in MongoDB and then you have some kind of dependency on it. Then you have you need to replicate the data, so it goes into MySQL. MySQL has its own replication, but now you need to have application code to put it into the Mongo Shield. And it adds another layer of complexity, like where is the problem from? Is it Mongo Shield or is it MySQL? This is actually a Mongo Shield, a real Mongo Shield. It's something they use, I think, in the South American jungles or African jungles, I'm not sure. It's quite large, it's quite tall, as you can see, and it protects from animals attacking you in the wild. I'm going to just pause a bit and talk about some things of cache. So the downsides of cache, obviously we've talked about stale data. The cost of generation, sometimes like the cost of generation is very high, and it's not worth it because it's cache, you may just get it directly. If you want to invalidate cache, so here we were talking about time to live, and with the notion that we accept staleness to some degree, but you may want to invalidate cache and then you need to have code. And if I'm not mistaken, for developers, cache invalidation is a very complex thing or not a very friendly things to go. You have cache misses and then you have to go to the actual table. You can have dependency, and I'll explain it in the next slide, and obviously maintenance. So with the memcache, there's no maintenance because you request it. If it's not there, you put it. But some with the interval one and the streaming or other things that I'll show you, you may actually need maintenance for them. So with the dependency, I have an example here. So pretend that's on the top there, the globe is a load balancer. Gives you a sticky session to your e-commerce website. You have the sessions on a memcached on two web servers. But because it's sticky, you just stick to one when a user comes in, and then you have the cart on MySQL. Let's say you say that a cart is a transient thing and doesn't need to reside in the database, and you do something like this, and you don't want sticky, so you basically have a server on its own that has memcache. It keeps the sessions and the cart there, and once the cart is agreed on and everything, and it goes into an order, it goes to MySQL. But here you don't have a sticky session, like it goes to any one of the servers and they can query memcached or MySQL and they'll get the same result. But the problem is now that you have to maintain memcached as its own server. If it crashes, what do you do? Do you need high availability for memcached? Do you need replication for memcached? So you have this issue of dependency. And you also have the issue of manipulating time. So I'll explain what I mean. So let's see. So there are basically 6 stages when you can implement some kind of caching on insert. So let's say, imagine you insert a row into the database, and on the same insert, you want to also update 2 other tables. You can do it asynchronously, so you update that table, but then it goes into some kind of queuing thing, like Gearman or ActiveMQ, and it updates it later. You can do, and there are caches, it's not all for memcache, there are different caches. The caches that you update for intervals, so like once an hour. Caches that you update off-peak, like once a day at 3 a.m. Prefetch, basically, like a typical, if you get a search result, you do the first page. While the user is looking at the first page, you're prefetching page 2, 3, and 4 already. And then, obviously, on request. And regarding error handling, on insert and request are the easiest because you get an error then and there, and you know what it's about. Asynchronous, it's harder. With Gilman, I think it gives you, like, it tells you this failed and what you can do about it. And intervals and off-peak, you can monitor the process and everything. There is a good use case for intervals and off-peak, and I'll explain. But you have all these options of manipulating time. It doesn't all have to be like when the user requests it. It can be like before or after, in the middle. Right, so moving to column cache. So this will be a bit unusual because I'm not sure if apart from denormalize, obviously, but this will be a bit unusual. So denormalize, basically, you're trying to prevent a join with denormalize. You are keeping usually an ID, an ID from another table, on purpose as additional data in a table. Meaning, you can get this ID if you do a join. You get it from another table, like an intermediate table, if it's from another table. But if it's like 1-to-1, and you can keep it in the same table, if you add a column that basically denormalizes, you prevent the join, you make it faster. Usually, as a rule of thumb, less joins you have, the faster it is. Not like in every case, but let's pretend in this case it will. Another idea of column cache is basically a subtotal. So imagine, you have a customers table, and for some unknown reason, you really need to know how much money these customers have outstanding instantly. Like you can't calculate it. It has to be really, really quick. I don't know why. So you have an additional column where it's temporary data, and every time, let's say, you insert a new order or they've paid for it, it updates this or whatnot. But it's an option there. It's not a very common one, but if it's really important, you can prevent like a whole group by 3 different tables, whatnot. Slap it into a column that may change, and you can get the result right away. So with the normalize, obviously the problem is maintenance, because you have to maintain this new order. You have to maintain this ID and keep updating it. It also takes more space on disk. The downside here is, again, you have to maintain this. Cost of generation may be very high. It may actually take a good few seconds to do it, and if you do it on insert, it may take a while. And again, you have this calculation of space versus speed. Okay, so you're getting into this idea. I know I'm increasing the space on disk. I know I'm denormalizing and doing the opposite of saving as much disk space as I can, but it speeds things up for me so much that I think it's worth it. So the denormalizing is more common. Subtotal is not very common, but denormalizing is somewhat common. You have conditional. You can have conditional column, and basically I've seen this before. When you have like is something, is like status columns, or is done, is good, or something like that, where you basically store a true or false logic, right? So your application has the logic, but the result of it is stored in a column. I'll give you an example of status. Let's say is done. You can say, give me all the orders that are done. So, or give me, or for reporting, you can say, give me everything that's above average. It's kind of like a yes/no thing. You keep the logic in your application code, but you store it in the database. So it's good if you have more than one application referencing the database, because you don't have to rewrite the logic. It's somewhat common. I've seen it a few times in older database designs, but yeah. So again, this prevents you recalculating the result, or keep like moving the logic into many applications. So attributes, you have something like enum, and just so you can appreciate, enum is it stores it like as a byte or 2 bytes, but you can keep like many sorry. Does anyone know what enum is here? Yeah, okay. Yes. So the benefit of enum here is that you prevent the join again, because you don't have to reference a description table. Obviously, you have to do an auto table every time you want to add an enum, but when you view the table, it's very visual, like it's there as the string, not the ID anymore. And you don't even handle the ID. The ID is handled on its own. So if it's things like male, female, something like that. What is that? Someone's smiling transgender also is an option. Okay, male, female, transgender. If it's something that doesn't really change very often, you can certainly consider something like that. Set data type. I've only used it once, but when I used it, it had like a lot of really, really good effect. It had like it's basically an attributes thing to, let's say, a customer, and you have things like let's just say customer, good customer as an option, bad customer, paid on time, outstanding, all these things are attributes. And you can have good customer and paid on time together, or 3 or 4 attributes, likes to go out. And the idea is that you prevent a join, and it's like enum, again, it's very visual. You can see it like when you do a select on the table. Stores it as a 1 byte or 2 bytes, depending how many options you use. A bit difficult to search on it, but again, may save you space, may prevent a join. I only used it once again, but it was quite cool when I did. And now you have a summary table. So this whole thing is very important to me. I live here now with my current client. I live with summary tables all day long. So summary table is an additional table. And so I think someone had a question about, if it has too many joins, what you can do about it. So this is really a good thing for that. It's an additional table which consists of an aggregation or another table, or of another table or several joined tables. So I'll show you what this is. Let's say you have this query. I'm usually going to talk about reporting queries here for the sake of argument. You have this massive query. You have, from main table 1, join table 2. Some of them may be just descriptions. Some of them may be actually big tables. Blah, 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 blah. So table 1, 2, 3, 4, 5, 6, 7, all the way to 10. Where T1 date between these 2 dates, group by date. It takes too long. It takes, you process a lot of tables. It takes 1.2 million rows. It returns 30 rows, and it takes 17.52 minutes, and that's just unacceptable from your customer's point of view. So what you can do is you can create a table before time or keep it updated, and this is what I meant by intervals and off-peak hours. You can create a summary table, and here you can see the statement, summary table, you give it a primary key. Automatically you do create table, select from, you do table 1, 2, 3, 4, and 6, and you group by these variables. And then when we go back to the origin table, we use the summary table, and ideally this should be only descriptive tables, like not big tables, but depends on what you can do and what you can't. From the date, same group by, but now we're processing 35,000 rows. It takes still 30 rows gives you back, and it takes 0.75 seconds. Okay, talking for reporting, very useful. The summary tables, you have to maintain them. You have to, do it once an hour, update them, or update, let's say once a day. So you update them at night with all the last information that was updated for that day, or if that's unacceptable, once an hour, once every 30 minutes. But for these kinds of queries, these summary tables are extremely useful. And basically, this is what it looks like. So you have all these tables. It's in the summary table. You join them one more time, or you can keep them as is, and you get the result much, much quicker. So again, you have duplicate data here, summarized data, but duplicate. You're taking up space again, but it's a lot faster. So this whole summary table thing, it's kind of like an analytics subsystem, and you may notice that summary tables, you can have one summary table, then you can have a second level of summary table of summaries table, and at some point you have a data warehouse, or at least a data mart. And I'll explain the benefits of data warehouse versus operational system. So I know this is taken from a book actually that I didn't write here. It's taken from a book, Star Schema, about star schemas. It's really a very nice book about design. So an operational system, the purpose of operations is what you guys, can't decide on. You need to execute business processes, and you design your database for that. Analytics system, on the other hand, is supposed to measure it or report on the measurement of the business process. The primary interactions with an operation system is, the insert, update, query, and delete. And on an analytics system, you basically just do selects. You design the operation system for update concurrency, very, very fast updates. And here you want to do high performance queries. Again, here it's third normal form, and here it's dimensional design. So I don't want to overload you, and let's just break it down ever so slightly. In data warehouse here, you have 2 tables, which is relevant here. You have the fact table, which is used for measurements, and you have the dimension table, which is for context of these measurements. And I'll explain in a minute how that works. The fact table is usually very narrow, as in fewer columns. The dimension table is very wide. The fact table, many, many rows, and the dimension table is fewer rows, but wider again. And the fact table contains most of the data, and the dimension tables are used for filters and descriptive data. Why is this relevant to anything I'm saying at the moment? So let's say with an operational design, we have I'll just do it quickly. We have like an orders table and orders items, which is connected to the orders. We have products connected to the order items, addresses connected to the customers and the orders, and the size of these tables, like on disk, looks kind of like this. So addresses relatively big, products are somewhat big, order items is quite big, orders is quite big, and customers is a bit less. And usually, for example, so if I were to want to have a query that says, okay, tell me how much money I sold for a particular city in the first quarter of the year. So I'd have to go to addresses, find all the addresses that are relevant to the city. I would have to join them to orders. And here it's not a filtering thing, it can multiply it, it's a one-to-many. Then I find all the orders, multiplying it, then I go to the order items and multiply it again. Then I find the orders to get the price, because the price is there, not there. So I have to do all this round trip, multiplying. It's very confusing, very intensive for the optimizer to get this report. Whereas a data warehouse with a star schema that's specifically designed for this, in the middle you have the fact table. I'm not trying to confuse you, and I think I already have a bit, but I'll explain how this works with summary tables. You have just the IDs that you're interested in, and then you have the price, like what you want to measure. So, and then you have on the other tables, you have address dimension, customer dimension. Because the order items is there, I've not had the need for orders table, because orders and order items are like just together now. They're multiplied, but they're together. And a product dimension. And there's a data dimension here as well. And just for example, why the data dimension sometimes comes up in data warehouses is for the following example. Let's say you wanted to know, give me how much products I've sold in the first quarter of the year. So quarter, you just say quarter equals 1, where it was a holiday or a weekend. Right, so you do weekend, holiday equals yes or whatnot, weekend equals yes. And it gives you this very, very quickly. It's very well optimized for these kinds of queries. You use a data dimension for filtering, you get back a certain number of variables, and you put it it filters all those items, and you get the result very quickly. In terms of table sizes, this is how it would look like. These tables are again very wide and very small, and the order items contains all the data. The idea that this is faster is because you have not done too many joins. The joins are not very heavy. These joins are used for filtering. It's one table. The optimizer will choose the best way to get you your data and give it quickly. This idea is how you would want your summary tables to look like. You would want the summary table to contain a lot of IDs and just something you're measuring. You would like it to be very narrow, and you would like the other things, which usually you don't do, or like the descriptive that you have anyway, to keep that information there and like use it as dimension and description. This is the ideal way. So if you would have a summary table, you would still leave the option of joining it to another table for descriptions, but this would make it like the ideal way for the optimizer to give you the results back. Maintenance for these summary tables. We have hourly, daily, weekly, monthly aggregations on intervals off peak, or you can do it on insert, but that's not very common. Like usually it's off peak once a day, or you can just add to the last one, say this is the total for that 1 hour. So this, I hope I haven't confused you with this example, but that's like the ideal way for summary tables to be designed, that you forget the idea that you have all these business processes, and you build your reporting style summary tables to contain this fashion of data, so you can display the data very quickly. Then what you can do is you can give this summary table usually to like the business users and say, off you go. Some people may know how to do SQL, some people may have some kind of business intelligence suite, they'll just connect to it, and you don't have to write queries anymore, they'll connect to it and do it on their own. Right, so we've done that. I've just finished the read cache. This is scaling reads, and we're almost at the end now. Just going to chat a bit more. So scaling reads, so you can see, I'm not sure if you can see on this slide, but you can certainly see on the PDF. We have the way to scale reads is making changes to indexes, partitioning, bezel hardware, read slaves, sharding, which we'll talk about, read cache, which we have talked about, and InnoDB buffer pool, which also includes other settings. The indexes and partitioning I've just finished because I've shown you how to do intensive table optimization. That's done. Read cache is done. So I'm going to adjust the other parts, and sharding is at the end as well. So scaling reads, basically InnoDB buffer pool is really the best way to have from my experience to scale reads. In this case, like try to give as much as you can before like running into swap. Make sure your cache is warm. You have all these other options like read buffer, soul buffer, or jump buffer, but they're not really something to play with. They're there, but I would focus your attention more on the InnoDB buffer pool, especially like, you know, if you don't want to go over tweaking. Sometimes you have this thing when you do like very heavy group by queries and you want the temp table size to be larger so it doesn't do a temporary table on disk, or you can put the temporary table in the dev shared memory. But, you know, again, I still think it's better to allocate memory to the InnoDB buffer than allocate memory to temp table size, or at least I used to be the other way around and I changed my mind to this. Better hardware, basically you're looking, you have this graph again. If you add more memory, you can keep more of the working set in memory, or if you can't, then get better disk I/O so you can read the data off the hardware better. Again, this isn't something in this for this tutorial, but at least you should know about it. Now, okay, so read slave. So this is really, you know, what MySQL is good at, scaling out. But the main problem that I found with adding read slave is the read-write splitting. So you start off with your app. When you start off, you usually don't consider read-write splitting, and then you have this app that, you know, you want to scale out, but you either have to make code changes now that you can know which one, that you can know like where to go. If you do make the code changes, you know, scaling out is practically infinite. If you know your writing isn't too much, you can keep one master or maybe two, and you can have as much read slaves as you want because you've split the traffic in your application. If you don't, and you have the option of, you know, having a master-master active-active kind of thing, where you basically add another server, you can write to both servers, they both replicate to one another, and you now have two servers instead of one. It's not a write scale because they both have to replicate, but now you have two servers. And I also think that if you can include Galera in this, and we had a conversation with Galera in this room before. Basically, Galera has like synchronous replication, but synchronous but on many threads, and you can have, let's say, at least 3, or you can have 5. I think that the more you have, because they all have to write to one another synchronously, the more you have, or let's say the speed of this cluster is judged by the slowest server. So the more you have, it may be a bit slow. But I think for read scaling, if you don't want to do read-write splitting, there's definitely an element there that can help you. But yeah, if you do read-write splitting, you know, it's easy. You just add another slave, no problem, read, send to it. So this is some example of some server architecture. How usually I've seen it happen. You have a web server with MySQL on it, so let's say like PHP on the same one, MySQL on it. Then you decide, actually I need MySQL to be on its own server. Then you decide maybe I can have a load balancer, 2 web servers and 1 MySQL server. Then it could be 2 MySQL, master-master here. You can have master-master and each one having a slave. We can have 2 proxies, so you don't have a single point of failure going to 2 web servers. Or you can have this new Galera thing, which would be like a cluster, and it's synchronous now, but it's still relatively new, or maybe not that it's new, I think. Moving on, so reporting. This deserves its own slide, its own part. All these parts I've done already for you, so we're only going to focus on the other side. So I'm going to start with reporting slaves. So I've already said that, so I don't know if you know this, but you don't have to have the same indexes on all the slaves, on your slaves. You can have certain indexes for the master servers and more or less indexes for reporting slaves. The data will still travel, will still get there, even in row-based replication. But the reporting slave, you may decide to have partitioning, which is different from the master. You may decide to have indexes, which is different from the master. You may decide not to have foreign keys. And it says that you must have the same data types, but again, Ben found a way that you don't have to do that. So the problem is that your slave now is different from your master, and you have to back up both separately. You have to back up the reporting slave here and the master there, and you can't use the reporting slave to rebuild the master. For example, it's a different thing, but you can quite easily say this slave is reporting. I don't care. I add indexes. I do completely different, no foreign keys, different data types, different partitioning. completely different from the master, and much more suited for reporting, and it will work. So reporting with sharding, so you have three options, and I'll tell you which one is the most common. You have cross-shard joins, which is very uncommon. So you have like, let's say, you have like data on different server or different shards, and you want to join all the data together. So you get the results from each one and join that. You can do that, not very common. You have go fish, which basically I only have data on one of the shards, and I don't know which shard it is, but I want to go fish where it is. I think DB scales do this. And then you have aggregation, which is basically Hadoop, which is the most common way. If you have shards and you're at the stage where you have shards, Hadoop basically fetches it and puts it into one reporting server, fetches it, aggregates it, and puts it into one reporting server. That's the most common usage that I've noticed. So reporting, we spoke about summary tables. I just want to say a few things. So, like summary tables, you need scripts to do. You can either do it with scripts like select, like insert into table for the last day, create table as select. You have Hadoop to do these aggregations for you, but again, these group bys are done very well within relation databases, and Hadoop is only like Hadoop. For example, if I have 7 servers, and I have Hadoop now, if I have 7 servers, it takes me 8 servers. It takes me just 7 seconds just to call everyone. And sometimes MySQL can get back like in 1.2 seconds for me, like some kind of query. So it definitely is an issue of size. Like if it's above a certain size, Hadoop, excellent, really good for this use case. If it's below, stick with MySQL. Hadoop, of course, can also make you ready-made report. It doesn't have to do aggregates. It can just give you a report, which you can email to your client. You can also do OLAP cubes, which is a multi-dimensional report. It's built on the star system, the star scheme that I explained earlier. What it is, it's basically a report. It's a static report. It has data, but it doesn't like reference any data. And what you do is you get this like grid on different columns and then you click on something, and it opens up a new report. And you click on that, and you drill down until you get to the data you want. But it's already made. It's not like you're accessing a table. It's like ready-made multi-dimensional report. It's quite cool. I think Last.fm use it, and I think Google Analytics use it. It makes like and Hadoop can make it as well. Hadoop can do something in Hadoop. You need like someone else to do it. You can make these multi-dimensional cubes and send it to a customer once a day, once an hour, whatnot. If you have a lot of summary tables, like my client does, you can use a columnar store, which is a different way of storing data, very useful for data warehouse, and that just costs money. So then you're like very expensive. So if you can keep it like within your realm of summary tables, if you do need to do reporting, or you need to get information from tables that have many joins, if you have a summary table, you can extend the lifetime of your MySQL by a lot. You can keep using MySQL, add some scripts to generate this summary table, and you can keep going for a while. Right. So we have write buffers, and we're almost at the end here. Write buffers, scaling writes, and sharding. Okay. So with write buffers, you can't really see it, but these top things, and that is ACID compliant. Underneath is less ACID compliant. Okay? And if that's important to you, then you know which ones to choose. So with write buffers, you have RAID with battery, and you do write back. So you have a RAID card. The RAID card has a battery. If your server goes down, the battery still it's fine. And what this means is you can write data to the cache of the RAID card. You won't even know this. And if it says like write back, then it's very fast. You don't have to wait for it to be written onto the hard disk. It just resides in the RAID cache of the RAID cache itself on the card, and it will write it to the hard disk later. And if the server goes down, it has a battery to write the remaining things. The problem with this is you have this thing. If it's write through, then it has to write through all the way to the hard disk, and it's usually slower. Problem with these batteries is that they try to learn how much battery they have left, so they drain themselves completely. And during this time, you have write through, and it's slower, and you don't know why. So again, I spoke about InnoDB log file size as a write buffer. So you hold like stuff that hasn't been applied yet to the data tables in a log file, and the larger it is, the more it can hold data. So basically, there's some kind of calculation with the buffer pool times dirty read times IO capacity, how quickly it writes to the hard disk and how much the hard disk can be written to. And this NW log file size, you can increase it, and you can increase. It will prevent the spikes when you have to wait for it to be written to the hard disk. Like if the NW log file size is full, it has to flush, and everything stalls till it has to flush. So you can increase that, and that may not happen to a later time, or not at all. I've spoken about these two, so I'll save you the effort now. Right, so these next two things I think are very interesting for you. So write buffers. You have basically, this isn't ACID compiled anymore. You have, instead of writing your writes to MySQL, you're writing it to a queue, like active in queue, rabbit queue, zero in queue, queueman. It's not ACID anymore, and you may need redundancy at this point. But I know, for example, that Gumtree uses this. They have like two queues, and they write to the queue. Like every time you want to write something, you write to the queue, and then it applies it to MySQL whenever MySQL gets run to it, or when it finishes. And this can increase your write because again, it puts it in a queue. You're dismissed. Your thread is dismissed, and you wait for the queue to happen. You should know that it may not happen instantaneously. So if you request that data, you need to know it may not be there yet. And yeah. Again, it's not ACID compliant because it keeps it in memory. If the server crashes, you need two servers now, so it's a bit more difficult, but it's, again, a form of write buffers. Summarize writes, so this is just quickly, basically, you have, example here is you have memcache counters, and once every 5 minutes you write to the database instead of like flooding the database with counters, right? So and the thing is, if you know the memcache crashes, you don't mind that much, so not really a big thing. Right, so this is really... It depends on your use case, but this is really important. So, in a lot of cases like advertising, games, telecoms, sometimes they have all these app servers, and these app servers are not connected to MySQL directly. They store data on the local. To scale the writes and not be dependent on MySQL, they store the data on the local server. So typically, it's in a log file. In most cases, the most popular is log file actually. Not in between the log files. But you can use Memcached, SQLite, like on disk, or SQLite has an in-memory version. You can have MySQL, but I don't recommend. Depends on your usage. And then what you have to do is later, after. So basically, you have a log file. Let's imagine a mobile phone company. You made a call log, just like an Apache log. You made a call log. This is how long it took, and when it happened, and another log, and it just sequentially updates the end of the file. Then you have like some kind of process where you grab that log file and put it in the database later. The idea is writing to the disk is a lot faster than waiting for MySQL to reply to confirm that it's written it, and it's also like very loosely coupled. So if this server goes away, you also have these other servers, and you'll get the data later, right? Like assuming the hard disk isn't fully corrupted or you have RAID or whatnot, you'll get the data later. It's written it. You're not dependent on MySQL. It's a lot faster, and in a lot of cases you don't actually need the whole data. Like the whole data is just zipped somewhere. You may need aggregations of that data, which is something else. But for write buffers, this is one of, depending on your usage, this is a very good use case. Really very common. So independent isolate needs to fetch data. So you may need like to prevent data misses or duplicates, but depends. If you use UUID, it doesn't have to. Actually, I don't know if that's Knichi, but yeah. Anyway, so write buffers. So once you have the data there, you need to do some kind of ETL process, which is extract, transform, and load. You can either do it with hand code, so you get the data from the logs or MySQL, depends what you chose to use. You can use an ETL tool like Pentaho or Talend, or you can use Flume, which is like with Hadoop. It basically tails a log and updates Hadoop with it. If you want to just aggregate it, like you don't really need the logs, you just want an aggregation of the logs, and you can do it with Hadoop, which is the most popular. And then you can do Google Crush tools, which is Google Custom Report something shell. I forgot. And we use it in the company I'm working at the moment. And it's kind of cool because basically this is how it works. You get an old log. It's all in pipes. You convert the date, you reorder it, you aggregate it, you output it to a CSV, and you gzip it again. then you like input into MySQL. Like no one knows about this. Even when I came into this company, it was no one knows about it. But it's the fact that you can pipe it means you can just create a bash thing. Forget about Hadoop and just get it. But yeah, normally Hadoop is the most popular choice if you have this kind of local storage. But think about it again. Like if you write a lot of data and you don't want to depend on MySQL, and it doesn't matter if it resides in MySQL now or like in 5 minutes later. This is really the best way. Just save it as a log on the file system and fetch it later. Okay. So scaling writes I talked about. So again, if you have less indexes, it writes faster. If you have partitioning, it may write faster. Write buffers we've talked about. Sharding we haven't talked about. So basically we have removed bottlenecks. So remove bottlenecks and hardware. So again, less indexes, less partitioning, blah blah. You can bypass the SQL layer, which Sergey here may have a lot more information about tomorrow than I have. The idea with a relation database, you have 3 layers basically. You have an SQL parser, an optimizer, and a storage engine. And if you bypass these 2 layers at the top, you can go directly to the storage engine. There's the InnoDB memcache, which hasn't come out yet, and you have handler socket at the moment. And it's very, very fast, especially with primary keys. So, and also I just want to mention that Reich, once upon a time, used InnoDB directly. It couldn't for a while. It couldn't afterwards because InnoDB wasn't the right GPU license, and they had to switch to something else. But writing to InnoDB and primary key lookups, primary key is really very, very fast. And Sergey he can explain more about that. Scaling right, so. Some things you can do, like to tweak the operating system. You can change the iOS scheduler to from CFQ to NUP or deadline. I won't explain why now. The file systems themselves, you can include no barrier, no wait time, no deal time. I don't think XT3 allows no barrier, but I'm pretty sure XT4 and XFS certainly does, and ZFS. And you can change the block size, but none of this is relevant to me. Just so you know about it. But yeah, if you can do these 3 things to your XT4 or XFS, it should improve right away, and iOS scheduler as well. But I don't know how much really. It depends, varies on system. So faster I/O, faster disk, SAS, SSD, RAID plus cache, PCI SSD, so Fusion or Viridiant. A master again does not scale writes because they have to replicate. Writes, sharding does scale writes, and here we go, sharding. Okay. So sharding we have. This is the last thing of the day. Sharding has partition data. So sorry, how do you partition the data for the sharding? Usually what keys, how do you use reporting, we kind of spoke about that. Also have functional partitioning, and how do you look up to which shard you should go to. So basically you need to pick how you want to partition the data, how you want to split the data. Typically it's vertically, so it's very much like the way partitioning works in MySQL at the moment, only each partition resides on a different server. What you need to do is you need to find the tables you want to partition. You need to find the child tables that are connected to those tables. So for example, if you want to partition orders, then order items is a child table of orders. You have to find the global tables, which is data that you want all shards to have, because if you don't want cross-shard joins, you want everything to just be done in one. So you want it to be shared nothing shards. Then you want to duplicate this global data across all the different shards, depending. And I think the most examples I've seen is by schema. So you have the shards are in different schemas. You can have it on. You can start off right now if you have a greenfields project. You have a database with sharding already there, and you have many schemas. So let's say you have customer ID, so customer database with customer ID 1 to 5. 6 to 10, and you can do it in different schemas. And then when you want to shard, you just move that database to another server. That's an option. Partitioning by key. So usually, again, customer ID, product ID, or by app. So I think a customer ID only if you have a really let's say you have a bunch of clients, and it's not like customer ID people on the web, you have a really big client and many small clients, and you may want to get 1 or 2 of the big clients, put them on their own server, and all the other small clients and put them on their own server, and then just have it done that way. You can do it by area, so country. So this shard is for North America, this is for South America, Europe. Or you can have it by hash, which is basically like some of the things like you may see that there's automatic sharding. They just do it randomly, and they keep where the data is in somewhere, and they'll do it for you. So that would be hash. So which shard has the data? So you're doing lookup. So you can do it in 3 ways. You can either store it in a database, so it's flexible but slow, because every time you want to do a database, you want to find out, you want to get to the right shard, you have to do like a database query. You can keep it in your app, in some kind of function. So it could be fast. It's faster but less flexible because you have to like deploy it and whatnot. Depends on you. Or you could keep it in a proxy config file. So you can have HA proxy, and you can give it a port, and you can say this is for this is for that. And then when it changes, or then when you have many, you just update the HA proxy. Although this is the least common, I think the first 2 ones are more common. In sharding, okay, so the problem with sharding is you have, maintenance. Now you have two databases. They each need their own backups. They may each need their own slaves. So you have all these kind of maintenance issues. One of the benefits is uptime. So you have like this loosely coupled system. So if the European servers go, like let's say you have North America and Europe, but North America is still there. So it's not like the website is down necessarily, because they're all separate now. They're loosely coupled. So you may never actually, so you may have issues with Europe, but the website is still up or whatnot for North America. And then you have functional partitioning, which is basically, I've seen this before, I've worked with some before, it's basically a different app. So you have 2 apps, but they share some tables. So you have to manage to get the data to both the database. You can either do it by having a main server and a master server, and just for those shared tables, and slave them off, replicate them off to those 2 master servers for the apps. Or you can just update the data manually. You can output it to a load data in file, and load it output in file. And or you can do what I don't recommend is, if it's MySQL, you can copy it to the MySQL table and just copy it over to another slave, like it's a big log file, which I've seen done. Don't recommend it. So reporting, we've talked about. You have Go Fish. Ideally, one server shared nothing. So you find the server, but it's not sharing anything else from somewhere else. Cross-shard many servers, and Hadoop. Actually, the Hadoop is more popular, so I'm just repeating myself. And we've finished. So now you are this, because you've listened to my presentation. And if you are male, now I've realized that when I wrote this that it's not very nice to compare, to reference females to bearded mature men. So if you're a woman, this is you now, because you're so cool you're not impressed. And questions and answers, and don't forget to rate my tutorial. Okay, so thank you very much. I hope it's been informative. I hope you were able to take something out of this tutorial, and that it helped you in some way. Thank you.